So hi to you watching this video. So for this video, we're going to discuss about module number 3, equilibrium of force system. So statics deals primarily with the description of the force, conditions necessary and sufficient to maintain the equilibrium of engineering structures. When we say equilibrium, it is in a state of balance, okay? Where the summation of forces in the moment is equivalent to 0, okay? This module constitutes the most important part of statics, and the procedures developed here form the basis for solving problems in both statics and dynamics. So the concepts involving forces, moments, couples, and resultants will be used on the application of the principles of equilibrium. Okay, so this module compromises one unit, and the unit is divided into 5 parts, namely engage, explore, explain, elaborate, and evaluate. Okay, so at the end of this unit, you should be able to solve problems involving equilibrium of force system. Okay, so you have here your engage. So before studying this unit, use the graphical method to solve the given problem below to recall what you've discussed in physics about the head-to-tail rule of constructing vector force diagrams and about Newton's first law of motion. Okay, so you have here your problem. Going to explore, read and understand the prepared lessons and find out how much you have learned about resultant of force systems by answering the activities under the elaborate and evaluate definition. Okay, so from the previous examples, we were able to solve the resultant of a force system or the resultant of a moment. Okay, so by now you should already be able to understand how to solve those problems. Okay, equilibrium. So the term used to designate the condition where the resultant of a force system is equivalent to 0. So from previous chapters, we were able to solve for the resultant of a force system, and it was equated to a or to a definite value. This time, the resultant of a force system will be equivalent to 0. Okay, so we will understand that further when we will be using it in an example. A body is to be in equilibrium when it is at rest or moving along a straight line path with a constant velocity. It can be in equilibrium when it is at rest, or if it is moving, it should be in a constant velocity. Equilibriant, a force which is equal to the magnitude and opposite to the direction of the resultant. I repeat, it is a force equal in magnitude, but it is opposite in the direction of the resultant. Okay? Equations of equilibrium. So when a body is in equilibrium, the resultant of all forces acting on it is 0. Thus, the resultant force R and the resultant couple M are both 0. So the summation of forces is equivalent to 0, and the summation of moment is equivalent to 0. Therefore, it is in a state of equilibrium. So we are going to use, or these two equations are equivalent to 6 scalar equations. The summation of forces along the x-axis or horizontal is equivalent to 0. The summation of forces along the y-axis or the vertical is equivalent to 0. The summation of forces along the z-axis is equivalent to 0. Likewise, with the moment along x, moment along y, and moment along z, all are equivalent to 0. If it satisfies this equation, then therefore it is in equilibrium. Okay. If all the forces summations are 0, the resultant cannot be a single force but may be a couple. The possibility of resultant being a couple is eliminated if all the moment summations are also 0. Okay, so free body diagram. So in solving for your problem, it is essential to consider all the forces acting on the body it is equally important to exclude any forces that is not directly applied to the body. Omitting a force or adding an extraneous one would destroy the condition of equilibrium. Therefore, the first step in solving the problem is to draw your free body diagram, or the FBD. So by now, you should be somehow acquainted in drawing your free body diagram because you already did this in your physics. So FBD, it is a sketch of isolated body showing all the forces that other bodies exert on the isolated body. But don't worry if you are not yet quite acquainted with free body diagram, we will still go through with it. Okay, just follow the discussion. So steps in constructing the free body diagram. Number one, sketch of the body is drawn assuming that all supports have been removed. Okay, all applied forces are drawn and labeled on the sketch. The weight of the body is considered to be applied force acting at the center of gravity. Of course, since it is a material, it will have a weight, and its weight is acting on the center of the gravity. Number three, the support reactions are drawn and labeled on the sketch. If if the sense of a reaction is unknown, it should be assumed. So we are going to assume the direction of the reaction. If it comes out to be negative, then our assumption of the direction is opposite. I is should be opposite. Okay. The solution will determine the correct sense. A positive result indicates that the assumed sense is correct, whereas a negative result means that the correct sense is opposite to the assumed sense or direction. All relevant angles and dimensions are shown on the sketch. Okay, so you should keep the following points in mind when you are drawing your free body diagram. Beneath, because the equilibrium equations will be delivered directly from the free body diagram, it is essential that the diagram is readable. Number two, clearly label all forces. Label all forces, all angles, and or distances with values if it is known, or symbols. Okay? The support reactions must be consistent with the information presented. And number four, show only forces that are external to the body. Internal forces will be in equal and opposite pairs and thus will not appear in the free body diagram. Internal forces will be dealt in mechanics of deformable bodies, and that is the next subject after statics. Okay, so we need to understand how are these forces acting. Okay, so modeling the action of forces into two-dimensional analysis. So we have here the type of contact and force origin. So we have here a flexible cable, belt, chain, and or rope. We have here a weight of cable which is negligible. If it is negligible, we can say that, or we can use the cable as a straight line. Okay, so we can conclude there an angle. But if the weight of the cable is not negligible, then we are going to create a parabolic curve. Okay, so the force exerted on the flexible cable is always tension. So no cable can resist compression due to its shape. It will always be in tension. And remember that uh, like for example, steel, which is a form of metal, is very high in resisting tension, but it is weak in compression uh, with respect to its shape. But if it is designed to a certain shape, it can resist compression. But on this case, since it is a cable and that is a circular for the cross section, then it is very weak in compression. Okay, for smooth surfaces, for smooth surfaces, you only have one contact force, and that is the normal force. Okay? Contact force is compressive and is normal to the surface. So this is the surface, this is your normal force if it is a smooth. But if it is a rough, then we are going to have two forces. Okay? So we have here the tangential and the normal. The tangential component of a force, or it is the frictional force, and you have here the normal force. Therefore, you can have your resultant force. If it is a roller support, always remember that a roller support only has one reaction or one force present. One reaction, one force. And it is always uh, normal, normal to the contact surface. Okay? Roller, rocker, or ball support transmits a compressive force normal to the supporting surface. So this is a roller, roller, roller. Okay? So freely sliding guide. So again, it is a normal force. Collar or slider free to move along smooth guides can support force normally to guide only. Okay. Next, if it is a pin connection, it has two reaction. You have reaction along the x-axis and you have a reaction along the y-axis. Okay. So a freely hinged pin is capable of supporting a force in any direction in the plane normal to the pin axis. We may either show two. Okay. So if it is a pin not free to turn, then we can now have a moment. It is now capable in resisting moment. Therefore, we're going to have a support for moment. But normally, when we use pin, it is a pin free to turn. So we only have two reactions. Okay. Next, we have a built-in or a fixed support. So for a built-in or fixed support, we have three reactions. We have the vertical, we have the horizontal, and we have the moment. So a built-in or fixed support is capable of supporting axial force F and a transverse force shear. So we have an axial force, we have a shear force, and we have a moment, bending moment. Okay, gravitational attraction. So we know that at the center of gravity, it is where the weight of the object is acting, and weight is equivalent to mass times the gravitational acceleration. Okay, and it is towards the center of the Earth. I repeat, it is always towards the center of the Earth. It is not perpendicular to any contact surface. It is always towards the center of the Earth. And number 9, spring action. This is in neutral position. It is linear. Okay. If it is linear, f is equivalent to the constant times the distance x. If it is nonlinear, okay, so we have here the hardening and we have here the softening. Spring force is tensile if spring is stretched, and compressive if compressed. Pag hinihila mo yan, yung spring na yan, nagiging tension. Okay? Kasi naka-stretch siya. Pero pag um, pinupush mo yung spring, it will be in compression. Parang itutulak din. Magka-counteract din yung spring natin ng compressive force. So for a linearly elastic spring, the stiffness K is the force required to deform the spring a unit distance. Okay? So normally, in what you're going to encounter most often would be a fixed support, a pin support, and a roller. I repeat, for roller, it only has one reaction. For a pin connection, it has two reactions. And for fixed support, it has three reactions. Okay, so let's proceed with sample free body diagram. So you have here a plane truss. So you have here a pin connection. So you have two reactions. The direction of this arrow can be assumed. Okay, so I can say that AX would be towards right, AY towards upward. If that would be the case, the answer would determine if your assumption is correct. If it comes out to be negative, then the direction should be otherwise compared to the assumed direction. Now you have B here, and it is a type of roller, therefore it has one reaction, and you have a force P. So this is my free body diagram. These are the only essential components needed to solve for the unknowns. Okay. Next, you have a cantilever beam. So cantilever beam, when we say cantilever beam, it only has one support, and the support is found at the end. Okay. So since a cantilever beam is a fixed support, we will be having three reactions. You have the vertical, the horizontal, and the moment. Then draw the forces present. And do not forget that your material also has a weight, and it is at the center of gravity. Okay. Next, you have here a beam connected to a pin, and it is in contact with a smooth surface. So you have here horizontal, vertical. So you have horizontal, vertical, and you have force P. You have there force P. Then you have here the normal force. That is a smooth plane. So you will only be having one reaction, and that is normal. Then the weight, it is always towards the center of uh, the earth. Okay. Then you have here your moment. A rigid system of interconnected bodies analyzed as a single unit. Okay, so you have here a type of roller, one reaction, normal to the contact surface. You have here a pin connection, so you have vertical, horizontal. Then you have here a weight, so mass times the gravitational acceleration. And you have here your force P. Okay, so an equilibrium of planar system. When we say planar system, it is two-dimensional. So we will only be needing three equations. So summation of forces along the x-axis, summation of forces along the y-axis, and summation of moment. Okay, so we can now proceed with our example. Okay, so we have here problem number 1. A 300-pound box is held at rest on a smooth incline by a force P, making an angle theta with the incline as shown. If theta here is 45 degrees, determine the value of P. Okay, so first we need to identify what are the given. So we have here the W, the weight is equivalent to 300 pounds. And our unknown here is the P. Okay, so if we are to draw that in a clear perspective, we will be having here our Cartesian plane. Okay, though they are not intersecting at a common point because the weight is acting at the center of the gravity, and we have it there. You have the 300 pounds. Okay, so assigning our axis. Let's say that this is my y-axis and this would be my x-axis. Okay, so that would make it a lot easier. Why? Since this is my y-axis, this would be my y-axis, and this is my x-axis. Take note that this is a 90 degree, and the angle here is the same as the angle here. Okay, so this would be a 30-degree angle. Therefore, this this would be my Wx, and this would be my Wy. Okay? If I am to redraw P, okay, we have here the P. So, again, this is my y-axis, and this here is my x-axis. And P is acting 45 degrees from the x-axis. Okay? Let's say that this is P and the angle here is 45 degrees. So from there, I can say also that this would be my Py, and here this would be my P of x. So using the equation of equilibrium, which is the summation of forces along the x-axis is equivalent to 0, all forces pointing towards that direction would be positive. So what are those forces? We have P of x. Okay, so P of x minus W of x. Are there any other forces? None. Okay, so that is equivalent to 0. So substituting the value of P of x, we have I know W of x, P of x is equivalent to, transpose this equation to the other side of the equation to make it positive, and W of x is equivalent to sine function sine 30. So we have sine 30 is equivalent to W of x over the hypotenuse of 300. Therefore, P of x is equivalent to 150. But we're not yet done, because what we're able to get is the P of x, and what we are interested into is to solve for the value of P. So to solve for the value of E, and since x is involved here, we're going to use the cosine function. Okay, so we have cosine 45 is equivalent to the adjacent side, and that is P of x, and P of x is equivalent to 150 over the hypotenuse of P. So cross multiply, P is equivalent to 150 divided by cosine 45. P therefore is equivalent to 106.07 pounds, and that is our answer. But you can also use another method in solving, and that is what we call the force triangle. Okay, force triangle, or it is what we call the Lami's theorem. I believe you have encountered this in your lower years. Okay, so what we're going to do is we're going to create a triangle, and we're going to use either the sine or the cosine law. So how are we going to do that? Okay, going back to the original figure, we have here force P, we have here the weight. Okay, and we will be having here a normal force. Always remember that in the contact surface between the object and the contact surface, we will always produce what we call the normal force. Okay? So this is our normal force. So from there, we can create a triangle. Okay? So let's copy. We have here P, P, then we have here W, then we have here the normal force. Okay, so we have P, W, and N. Okay, so the angle between W and N, so this is W and N, this is 30 degrees, therefore this is also 30 degrees. Therefore, the angle here would be 30 degrees. Okay, the angle with respect to P, the angle of P with respect to the x-axis is 45 degrees. Therefore, the angle with respect to the y-axis is 45 degrees. So either way, the angle here would be 45 degrees. Now, the interior angle of a triangle is 180 degrees, and that is equivalent to 180 minus 45 minus 30. The angle here would be 105 degrees. Okay? So, we are given the value of W, and that is 300 pounds. Okay? And what we need to solve would be the value of P. So, we can either use the sine or the cosine law here. No, we cannot use the cosine law because we only have one unknown side, one known side, and that is W. So what we're going to use would be the sine law. So for the sine law, we have W 300 divided by sine 45. Then for the P, it would be the value of P over sine 30. Okay, so cross multiply, we will be having P is equivalent to 300 sine 30 over sine 45. Therefore, P is equivalent to 202. Wait. The answer here is 212.13. We have an error. Let's double check this here. It should be greater because it was divided by cosine. So 150 divided by cosine 45. Okay, so it is not 106. P is equivalent to 212.13 pounds. Okay, so both have the same answer. So double check your answer when you're inputting values from your calculator, because you might get the wrong values from there. Okay, so we have here problem number 2. In the figure, P is known to be 160 pounds. So P here is 160 pounds. Then determine the values of alpha, and angle theta, so that it would maintain an equilibrium. So we have here a 200-pound weight or force. Okay, so since I assume this would be a rope, here it would be a 200 pounds. Okay, so what we're going to do is to redraw that into its free body diagram, or redraw the free body diagram. So we have here the 300 pounds. So we have here W 300 pounds. Then we have here P to be 160 pounds. Then we have here, let's say that is in tension of 2,000 pounds. Okay, so that would be in tension of 200 pounds. Our unknown is angle alpha and angle theta. So using the equations of equilibrium, okay, summation of forces vertical is equivalent to 0. All forces that are pointing upwards should be positive. Okay, so what are the forces? We have negative 300 because it is pointing upward, and since my unknown here is theta and lambda, I'll be using the cosine function rather than the sine function. So cosine plus cosine theta is equivalent to P of y. So I'll be having here P of y. Then we have here T of y. Okay, so cosine theta is equivalent to P of y over the hypotenuse of 160 plus, again same, cosine alpha is equivalent to T of y over 200 cross multiply, and that is equivalent to um, 0. Okay, so if we are to simplify this, it will simply look like this. So 160 cosine theta plus 200 cosine alpha is equivalent to negative, a positive 300. And this would be my equation number 1. Okay. Next, summation of forces horizontal is equivalent to 0. All forces pointing towards right should be positive. Okay. So I'll be having here, this would be my P of X, and here would be my P of Y. Okay. So, summation of forces horizontal, all forces towards right should be positive. So, what are the forces? So, I have here P of X and P of X, so that would be sine. So, that is sine theta is equivalent to P of X over the hypotenuse of 160. So, cross multiply, it would be 160 sine theta minus P of Y, that would be sine ty. No, this should be ty. Ty is equivalent to ty over the hypotenuse of 200, then cross multiply is equivalent to 0. Okay, so let's simplify this equation. So 160, uh no, we have here 160 sine theta is equivalent to transpose this to the other side of the equation to make it positive. So that would become 200 sine alpha. Okay, so here we have two unknowns, two equations. Therefore, we can solve our unknowns. Okay, so let's further simplify. Sine theta is equivalent to 200 sine alpha divided by 160. Therefore, theta is equivalent to arc sine of 200 sine alpha over 160, and that is the equation of theta, and that is my second equation. So substituting this to my first equation, I can solve for the value of alpha. Okay, so we have 160 cosine of arc sine of 200 sine alpha over 160 plus 200 cosine alpha is equivalent to 300. So input this in your calculator, and the answer would be 160 cosine of arc sine of 200 sine alpha x divided by 160 plus 200 cosine alpha x is equivalent to 300, and the answer would be 29.54 degrees. So angle alpha is equivalent to 29.54 degrees. Okay, then substituting the value of alpha in our equation, we have here theta. Theta is equivalent to arc sine 200 sine 29.54 degrees divided by 160. Therefore, theta is equivalent to arc sine of 200 sine 29.54 divided by 160. Theta therefore is equivalent to 338.05 degrees. Okay, so that is the value of theta and alpha. But there is another way of solving it again, using Lami's theorem. Okay, so using Lami's theorem, we can solve it again. So how are we going to do that? Let us draw our triangle. So going back to the main figure, we have here the 200 pounds. We have here the 160 pound, and we have here the weight. Right? So let's redraw our figure. So we have here our 200 pounds. Then we have here our 160 pounds. And we have here the weight, which is a downward force of 300 pounds. And what are the angle? Okay, so the angle that we're looking for here is, this is theta, this is alpha. Okay, saan nanggaling si theta and si alpha? If you can recall, or you can redraw that. Okay, so this is alpha, this is theta. So if I am to create, okay, so this here is theta. Therefore, if I'm to redraw that there, the angle here would also be theta. So doon ang galing si theta, complementary angles. Likewise with angle alpha. So for angle alpha, if I'm to draw a Cartesian plane, there here we have here angle alpha. Okay, so if I am to draw another Cartesian plane there, therefore uh, the angle here would be alpha, so that is the same, alpha. So theta and alpha. Okay, so we can now solve for the angles. So take note, for the angles, we have here two unknown angles. We have three known sides. So we can use the cosine law. Okay, so this is an alternate solution. So for the alternate solution, we're going to use the Lami's theorem. So we have here cosine. So cosine of 300 squared, or no, yeah, either way, kahit ano naman. Pero let's use na lang the 200 because our unknown is theta and lambda. Because if we're going to use the 300 squared is equivalent to, we're going to solve this angle here, which is not necessarily needed. Okay, so we have here 200 squared is equivalent to 160 squared plus 300 squared minus 2 times 160 times 300 cosine theta. Okay, so we can input it directly to our calculator. So we have here 200 squared is equivalent to the square root of 160 squared plus 300, no, walang square root kasi naka-squared property sila, plus 300 squared minus 2 times 160 times 300 cosine alpha x. Shift solve. Shift solve. Then angle theta therefore is equivalent to 38.05 degrees. Okay, so we used here the cosine law. Okay, so using the sine law, since we already have here our theta, we have 160 over 160 over sine alpha, and we have here angle theta, so that is 200 over sine theta. So that is 38.05 degrees. So alpha therefore is equivalent to 160 divided by sine alpha is equivalent to 200 over sine. Shift solve. And angle alpha should be the same. That should be 29.54. And the answer is equivalent to 29.54 degrees. And they are the same. Okay, so either way, it should generate you the same answer. Okay? Okay, so we have here problem number 3. Cords are looped around a small spacer separating two cylinders. Okay, each weight 400 pounds and pass as shown in the figure. So over frictionless pulleys, two weights of 200 pounds and 600 pounds, determine the angle theta. So this is angle theta and the normal reaction between the cylinders and the smooth surface. Okay, so this is the cylinder and this is our smooth surface, which is inclined at a 15-degree angle with respect to the horizontal. The first thing that we need to do is draw our free body diagram. Okay, so let's say I am going to tilt my x and y axis so that it would be a lot easier, though you can use naman the correct convention, no, of doing your x and y axis. Okay, so pwedeng paganyan yung y axis niya and your x axis would be horizontal. Okay, but in my case I'll use the y axis as inclined. Okay, so draw the free body diagram. What are the forces? We have here a 200-pound force. Why is it 200 pounds? Because this is a frictionless pulley. Okay, and ropes are carrying tension forces. So we have here 200 pounds, and we know that this is a 15-degree angle. Okay. Next would be the 600 pounds. So we have here the 600-pound force. So 600 pounds, and we have here our normal force. So this is no, n is upwards. It should not be downwards. And we have here the weight, and the weight is equivalent to 800 pounds. Okay, tapos dito would also be 15 degrees, and the angle here now will change. Okay, because the angle here is theta, but I used to follow a different axis. Okay, so this would be theta minus 15 degrees, and this is my y-axis, this is my x-axis. Okay, so solving for that, we can now solve for at least one. So this is n. So let's try to use, because if I'm going to use the forces vertical here, I will be having two unknowns. That would be theta and n. But if I'll be using the summation of forces horizontal, my only unknown for the meantime would be theta. That's why I also use this orientation kasi mas madali siya. Because if I'll be using the vertical and the horizontal as my y and x axis, two unknowns, two equations tayo kaagad. Okay? So, solving, summation of forces along the x-axis is equivalent to 0. All forces that are pointing to that direction should be positive. So, what are those forces? So, we have here this one, and this one. Okay? So, 200, and that would be cosine. So, cosine 15 is equivalent to uh, the horizontal component of 200 over the hypotenuse of 200, cross multiply. So that is 200 cosine 15. Next would be this. So since that is the angle, it would be sine function, sine 15, and it is negative because it is pointing otherwise, opposite the positive direction. So minus minus, so that is sine 15 opposite, 800, opposite of the horizontal component of 800 over the hypotenuse of 800, cross multiply. And lastly, we have the 600 pound force, and that is towards the positive direction. So that is plus. And we're going to use the cosine function. So cosine theta minus 15 is equivalent to the horizontal component of 600 over 600. Cross multiply 600 and this would be your term. And that is equivalent to 0. Theta, therefore, is equivalent to, let's input this in our calculator. We have negative 200 cosine 15 minus 800 sine 15 plus 600 cosine alpha x minus 15, and that is equivalent to 0. Theta, therefore, is equivalent to 63.16 degrees. Okay, then we can now solve for the n. And we're going to use another equation of equilibrium, and that is summation of forces along the y-axis is equivalent to 0. All forces that are pointing towards direction, that direction which is more or less south, north, west, should be positive. So we have 200 pointing upwards with respect to our axis. So that is positive, and that is a sine function. So sine 15 over the vertical component of 200 over 200, so cross multiply, that would be the term, plus we have here 600, so 600 sine of 63.16 degrees, 16.63 degrees, and we have here 800, and that would be cosine, and that is negative 800 cosine 15 plus n equals 0. So input that in your calculator. 200 sine 15 plus 600 sine 63.16 minus 800 cosine 15 plus alpha x is equivalent to 0. And wait. And the answer is 219, which is incorrect. Why? Because the angle here is theta minus 15 degrees. So the angle here should be, this term is incorrect. So we have here minus, plus 600 sine 63.16 minus 15 degrees. Okay? So that is incorrect. So minus 15. And the answer is 273.97 pounds. And that is the normal force. This is your angle.